Hi, my name is Rushikesh, and today we will try learn something about how one can sort cyber-physical relevant binaries, maybe malicious, maybe benign, from from a lot of collection of, we can say, other binaries. So yeah, that's me. I work at Mandiant as a researcher. Most of the time, yeah, most of the times working on some terminal. So please forgive me if there is some mistake onto presentation part. I'm really not good at user interfaces. And yeah, I love diving deeper into networks, wireless data link layers, memories, formal methods, and to some extent. And yeah, I'm a big fan and small contributor of Linux kernel. So I try find security bugs in Linux kernel and try to patch them upstream. So far, not so successful in doing that though. So yes, this slide. There might be a question like, why suddenly this slide? Reason being, let me tell you some small story, like how this whole thing began. I mean, how this whole exploration began. Like when I started working in the cyber physical relevant threats research team in Mandiant, initially I went ahead with the normal, we can say, normal flow of hunting specific binaries, specific threats. So like apart from dark web onto various file aggregation engines, there were like a lot of binaries. So I did the typical search for, say, SCARA or say PLC or something, and I got, like, thousands of results in written. That was tricky to handle because that was not time efficient as well as resource efficient. So I started drilling deeper, and when I tried analyzing these all type of samples which were not so closely relevant to cyber physical systems yet had something to do with cyber physical systems, there were obvious questions coming from the other end of the team. Like, I'm part of research and there is another analysis team. So they came up with a question saying, okay, you say this is cyber physical relevant binary, why so? While answering these questions, I was fortunate enough to come up with certain selection criteria, certain test of deductions, which actually helped me, we can say, second my own opinion or my own thought, saying, okay, these are the reasons that makes this particular executable file sample as cyber physical relevant. So this whole talk is going to be around this excursion, we can say. Yeah, so coming back to this same slide, OT malware. Back in 2010, Stuxnet was uncovered. We don't know before that how many years the Stuxnet was in operation and was evolving. Now we are in 2022. If you see the numbers, Stuxnet 2010, 2014 Black Energy, 2015 Destroyer, 2016 Iron Gate, 2017 Triton, and recently there was Intercontroller. 1, 2, 3, 4, 5, 6. 12 years and only 6 campaign. Honestly, I was not convinced. There must have been something huge number of things going on which we are missing. Maybe from detecting, maybe from some technical limitations, or maybe something else. So again, my tests of deductions were my small contribution, or rather are my small contribution to kind of, come up with some bigger numbers here, maybe in future, but yes, that's the whole thing. So I believe this explains like why we need to understand more about OT binaries. Okay, my apologies, I didn't mention. OT stands for operational technologies, for those who are not aware. Yes, this slide basically seconds this one. Just because there are 5 or 6 campaigns uncovered in last 12 years, we are feeling happy. Okay, there is something burning around, but we are least bothered just because we are not aware of that particular thing, right? Now let's come to the point, why can't we find this particular type of samples? While doing analysis onto various sandboxes, manually, static, dynamic, multiple things, I have observed many things. Majority of the sandboxes that do analyze malware, so that matter, they have certain preset rules available. And, excuse me, many of the times the cyber-physical relevant binaries were flagged, legit cyber-physical relevant binaries were flagged as malicious just because they were doing something which was defeating the rules there, or which was basically going against the rules into the sandboxes. That was one of the earlier days when I tried showing in almost every other binary which was having some similarity to cyber-physical relevance. And I got like, a number of wrongly reported behaviors from sandboxes. So that was one thing. Another thing, low visibility into OT systems. Yes, this is one of really, really big thing. Reason being, the softwares that we use in OT, they are custom made. So obviously, just by doing a search on any search engine, we don't get a lot of information related to that software, neither the software as well. Other part of the story is like, even if you get a part of software, there are multiple, we can say, parts you need to recombine, and then the actual executable will trigger. Plus, these things are super expensive. The typical operational technology setups, including hardware and software, they are super expensive. That makes them little less prevalent onto internet, we can say. When I say internet, for searching purpose. So I'm not talking about Shodan search or something. The third thing, few motivated actors. So far, yes. There were not many actors who were interested in cyber-physical relevant targets. Reason being, somebody or other majority of actors, they wanted something in return. So OT systems were not really targeted by them because of obvious, not much of a, we can say, return on investment type of thing happening there. And yes, the last one, not documented or undetected. Yes, as I said already, like, these things, I mean, the cyber-physical relevant softwares and hardwares are little less prevalent on internet to search or to download, we can say. And when I say not documented and undetected, reason being, suppose there is a custom protocol written for, say, a very specific functionality. For example, operating a sugarcane juice mechanism, for example. So we won't find any specific documentation, how the protocol was written, which protocol was used, and how that was passed onto the other side of the sensor network. So obviously, if we try to target that particular type of a setup, that is going to be challenged because nothing is available. So that makes it whole operational technology, we can say, little difficult to detect. So let's begin the search. Some basic graphic understanding of what exactly OT is and where exactly it sits into our whole internet architecture, or for that matter, ICT. Majority of the times, OT is sitting in between your normal network and a specific network. People say like, okay, we have our OT setup, which is completely isolated from internet, but then the fact is, the machine operator was able to access some of his emails, which was supposed to be only operated from internet. So that way there was some access on such systems. So that is why there is an overlap between normal operating environment and OT operating environment. Yes, so coming back to the same question again and again, what we see here is self-explanatory, I would say. What in a normal side, what we perceive as a normal activity is actually kind of really tricky activity to be considered in case of malicious behavior. The graphic says it all. I think I shouldn't say anything beyond that. So yes, we need legit OT binaries for various things. But then again, what is the problem here? As we have already discussed, no documentation available for them for multiple reasons. and cryptic and unique behavior. So here, when I say cryptic and unique behaviors, let me give you an example. Say, suppose there is a Modbus protocol implementation. It is speaking to some server and some client. The server is sitting somewhere outside the the client is sitting somewhere outside the normal network periphery, but is connected to the network. My typical malware sandbox will say, okay, there is some PCAP being generated because of so and so traffic that's happening between client and server. Server sitting inside gives a red flag saying, okay, this is something tricky happening, some compromise or something of that sort. But is it really so? No, because that's the typical implementation of, we can say, Modbus protocol per se. Closed source development, yes, many of the times, even if we get some particular binary to analyze, it is stripped one. You won't find any debug symbols. So little more difficult basically to analyze them. Yes, again, like specific to proprietary and private devices, as I have already told, these are custom made things, like, specifically built for a specific purpose. So tricky. Yes, I have already discussed, usually distributed in parts. The last 2 points are more interesting one. Huge variety of manufacturers and devices, and more functions, more codes, more secrets. So, so for one particular functionality or for maybe one particular purpose, if a person decides not to buy something which is readily available in the market, they'll go and develop that thing on their own. Custom hardwares, that makes it makes it more easy sometimes to develop such things, and that makes it the number of such implementations that keeps growing just because of similar things. So where exactly can we find these all OT binaries? First thing is aggregation engines, file aggregation engines, like malware analysis platforms, OT users or manufacturers. I have found many of such samples in their discussion forums. So like usually there is somebody complaining about, okay, I'm trying to run so and so exe and I'm not getting so and so sensor data or so and so client data, how to go ahead. And then at many places I have found the person actually mentioning every minute detail about the executable he is trying to trigger, including his credentials. So that was again really tricky thing. And in-house collection, yes. So that was something we have been trying to do with the help of some companies or with the help of some vendors. So that was a lot of theory, a lot of boring thing. Let's go to tests of deduction. So far, I was able to come up with these many criterias, 1, 2, 3, 4, 8 in number. They are not just 8 in number, they could be many more, or could be reduced or compressed to something small as well. So these are some of the tests of deduction for maybe a threat researcher or a SOC analyst to determine if the binary in question is cyber physical relevant, is actually having some cyber physical relevant content or not. So let's look at them one by one. Static strings, very basic approach. Most of the Windows and Linux systems are equipped with those commands. As you can see here, I have just run the binary with strings as a command and have seen some interesting keywords coming up into the terminal. Say like PLC station number, very specific occurrence from Modbus perspective. So a small demo. I actually wanted to show you live demo, but my demo machine basically got crashed. So I have some pre-recorded demo here to show you. So it's the same strings command that I'm running over a specific file. You could see it dropped everything available onto that file as text. Yeah. So you could see a couple of entries there mentioning PLCs, and these are from the binaries. So something that can be used as one of the convincing factor that the binary under examination is cyber physical relevant one. Another thing that was like status strings which were available onto or into the executable. The another one is from dynamic strings. So here we tried do some formal methods related work. There's actually a tool called floss, and we have used that tool to kind of carve some of the some such strings from memory as well. So let's see a demo for that too. You could see that I have used a tool called floss. So everything that you would see in the demos is available online and is open source. So there is nothing something enterprise thing that I'm using here. Now, if you just compare these two outcomes, the first one is from the dynamic strings outcome, and second one is static strings. You could see dynamic strings actually spilled a couple of more interesting entries there. Yes, so this is something which will actually convince us in little more depth that whatever the binary that we are trying to analyze is cyber physical relevant. Here we are trying to drill a little deeper and understand if there is any presence of a very specific function which is dealing with cyber physical systems. So I have used here a tool called yara, again openly available for reverse engineering. Or actually it's not reverse engineering, it's just exploring the things around. So let's begin. Okay, so in this particular video, I'm showing usage of R2, that's actually radar A2, another openly available debugger and disassembler. So, and purposely I have written the name of file as modbus PLC so that we will have some understanding about what exactly we are trying to target. So I have just run I as a command, and I have seen a lot many functions and other calls making a presence here. That again is something really tricky to go one by one. So I tried see if something of this sort is happening before going further. Oh, sorry, I just missed it. It seems. Okay. Yeah, before going further, I wanted, oh, sorry. Yes, I wanted to share something about this particular open thing. So why did I try and search open as a keyword into this whole functional or API calls which were being recorded or rather being analyzed by R2, radar A2? For all of the operating systems in the world that we use so far, everything that we read or write from is a file. No matter if that is actually a file or if that is a device. So this was actually an approach where I tried see if the binary in its context is trying to reach out to a specific device, and the best way to find that is see if there is any open call available or open file call available specifically. That way I'll be able to understand if there is anything which is actually if there is any functionality which is trying to reach out to some hardware or some virtual device or some sensor outside the binary. So was the reason of that particular search, open. And you could see that the first entry there that says open file. I think I reset the whole. Just a second. Yeah. So now I'm trying search for open as a keyword into the list of available calls, you can say. Now let's try digging deeper into the first entry, that is open file, and see if something of interest could be found. Yeah, again we got 2 entries in there. So I'll try drill deeper into the first entry out of the 2s. Something interesting was shown there, sim.modbus.exe something something something, but again not much of the convincing power it has so far. So I'll try seek that particular res and see if something could be found there. Yes, bingo. Here, string error accessing coil register address field. This is a very specific description of behavior of Modbus relevant binaries. This gives me a proper proof or an evidence that the binary that I'm trying to analyze is cyber-physical relevant one. Now let's go to another demo. Let me just quickly forward it. Oh, sorry, it was not highlighted earlier. Oh, same thing was repeated. Okay, now we'll try to see the same demo from Gidra. I'll just skip some first steps here so that we could expedite. Yeah. So here as well, I was trying search, find the presence of cyber-physical relevant functionalities, and yes, like every other lazy person, I tried search interesting strings, interesting functions, using some of Gidra's inbuilt capabilities here. So this particular thing filter, I later discovered that can actually be used to search some interesting functions as well. So this whole video is not only about success of how did I find something, but is also about the failures, how I could not find something. So like for coil, there was no interesting thing I could find in the symbol tree. So then I resorted to another search. Yes, so here I got some interesting instances like LPLC strings and the other one which was like from ifconf.h. Yes, this was the again concrete evidence I was able to establish if it is PLC that I'm dealing with into the particular sample. And then resorting to typical string search, including Pascal strings as well, and then filtering those search for very specific keywords. Yeah, as we could see, like, PLC station number, again very unique occurrence for cyber physical relevance, I would say. Yeah. Okay, so there are a couple of more. So similar thing I tried with Modbus, Modbus TCP, Cybus, Spabus, libiec 61850, Goose, Goose over TCP as well. We will go through each of them one by one. So yeah, now we have got another proof that whatever we are dealing with is again having functionality specific to Modbus TCP as well. Okay, so there is some serial protocol involved, ETH stands for maybe Ethernet. So this was just like some set of explorations. Okay. I won't be able to show demo on this particular slide, fuzzy hash or import hash, because of some tricky nature or behavior of samples, we can say. But what here exactly I'm trying to do, like, in previous demos, we have seen some very specific functions being used, some very specific calls being made. So we can actually calculate a fuzzy hash for similar isolated functions and can run them through maybe various hunting mechanisms to see if there is any match available. API sequences, another very important thing I would say. Those who are malware researchers here or reverse engineers, they know very well why this is important. Because those who are seasoned malware researchers, they can actually identify whole malware, including the campaign and family, just by looking at the API call sequences being made into the binary itself. So similar approach can be used in cyber physical or while establishing cyber physical relevant behavior of a binary as well. Device probes, as we have already seen in the demo, device probes is one of really very important thing. Reason being, say if we consider 100 cyber physical relevant samples, 98 of them will be trying to speak to some device. Could be internally, could be externally, could be onto network, could be onto maybe some other custom protocol, maybe onto wire, could be anything, right? So finding these device probes can actually give us more, or rather can give our statement more strength about the cyber physical relevance presence. So again, a small demo here. Louder. So again, same thing. So let's not waste time in this demo. Same demo, but from a different perspective I'm trying to show you, because the coils are nothing but a remotely available some hardware, maybe sensors, analogous to sensors, which we can say. And yeah, so here comes the network device probes. Reason being, as sensors, they majority of the times have some capability to speak on network, majority of the times, not always. They would be interesting things to look at or to search for. So this was the demo. Let's begin. I'll skip the part which is actually time consuming for no reason. Yes, if you look at the string that we tried find here is like IEC 61850. Those who know, this is nothing but kind of we can say power distribution relevant technology or a standard that we use. So IEC 61850_S maybe slave. Goose, another power transmission related implementation that we use. Spabus, another interesting cyber physical relevant implementation. So that says t underscore spabus underscore m, so maybe master instance. Okay. So here I have tried enumerate some more such cyber physical relevant setups, we can say, or functions. So okay, I probably missed the earlier one, the IEC 104. Or is it looping? Just a second. Yes. So here again, I have used Radare 2 to find some different functions or protocol which are specific to cyber physical systems. So again, I have used some different binary here for analysis purpose, and I purposely fast forwarded initial steps that as we have already gone through them. As you could see, the occurrences. So same thing we can do with Ghidra as well as with Radare. I just am trying to highlight everything that I was able to find using these all explorations. That's it. So yes, those were some of the demos. I actually wanted to show you them all live, but my setup could not run it properly, or basically it was messing up into my setup that I'm going to use tomorrow in my workshop. So yes, Yara rules. So majority of the things that we have seen so far can actually be converted to Yara rules and can be used as a detection mechanism. But when I tried to do that, majority of those Yara rules were found to be a little more noisy than expected. So sometimes I have got 10,000 hits, 20,000 hits for something really not so obvious. Results. This whole thing took me a few months to basically formulate and come up with some results. Results were honestly average, we can say. I was actually able to build some data set which can be used as a benchmark to begin with in cyber physical threat hunting process, we can say. If we could automate these all tests, which are really easy to automate, which we did as well, that would be a lot of less effort overhead, we can say. For example, per day there are around 150,000 uploads on famous malware aggregation engines. Sorting through them is really tricky if we happen to download them all and then do the analysis part. So here the automation can actually help. Yes, as has already been mentioned, it can actually help in expediting or analysis part as well. For the same reason, out of 100, if there are one or two which are actually cyber physical relevant binaries, then we need not analyze those 100 and then reach to the conclusion, okay, these are the cyber physical relevant binaries. Instead, we can pick the cyber physical relevant binaries and then go ahead and do the proper analysis on them. Excuse me. Yes, as already I have spoken, it helps reducing clutter, and the benchmark can be set quickly. So after going through these all tests, we can say there is no silver bullet. There is no we can say a checkbox things. Okay, these things, and you are hitting the cyber physical relevant sample. But whatever the tests of deductions that we have discussed so far can actually help us isolate some relatively relevant samples from say like per day upload of 150,000 samples. So that's most of it I had to share so far. There is a lot of development also happening into this particular topic. So far, I have no approvals to share that thing on the stage. But as soon as I get that, I'll probably come up with more ideas to present as well. So there are already things, there are already developments in place for this. So and this talk was actually meant to share how from a completely unknown territory we can go ahead in hunting some very specific type of binaries. So that's it.